Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. On, and in this tutorial video, I'll go through these 9701s. This is from June 2015. This is paper 4 variant 1. So from the older syllabus, so prior to 2016 revamp, we used to have section A and section B. So of course there are some stuff, there was quite a big revamp, that there was some stuff from the old syllabus, they are no longer relevant to the current 2022 specification, for example. So I will inform you as we go through the paper, and there will be some biochemistry question in the section B that will totally not be relevant to the new specification anymore. So in this first question, complete the electronic configurations of the following atoms. So these are straight AS level electronic configuration. If you have oxygen, you know that this is period 2 and there's group 16. So we're looking at 1s2, 2s2, 2p6, and period 2, so there's 2p4, so 2 plus 4, 6 electrons in the outer shell, group 16. Fluorine is just next to oxygen, so it's 2s2, 2p5 is 1 electron short from a fully filled outer shell. In the second question, a compound of fluorine and oxygen contains 3 atoms in each molecule. So if you think about fluorine, so this is going back to your O-level or IGCSE level or GCSE level chemistry in terms of 2-7 electronic configuration, just a really simplified configuration. We look at the number of outer shell electrons, and then valency is what you call the combining power. So we're looking at valency of 1 and valency of 2 because these are how many electrons each of them need to share to complete the outer shell. And then you do the crisscrossing. That is basically the lowest common multiple of the valency, LCM, primary school mathematics. You need 2 of the fluorine, this thing here, fluorine, 2 of them, and you need 1 of these oxygens, such that your formula is going to be F2O. If I draw the dot and cross, before I do the dot and cross, I'm going to draw the display formula. So it looks like water. Instead of hydrogen, forming a single covalent bond to hydrogen, you have fluorine, the group 17 halogens that form a single covalent bond to the group 16 oxygen there. So predicting its formula, F2O, drawing the dot and cross, this is not dot and cross, this is simply a display formula. But looking at the single covalent bond, that is a dot and a cross. Looking at the other single covalent bond, there's a dot and a cross, but we gotta show all the outer shell electrons, even though when the question doesn't say, dot and cross means show all the outer shell electrons. So if I do crosses on the oxygen, I started with 6 crosses, 1 2 3 4 5 6, and I share 2 electrons each from each of the each electron from each of these fluorine atom. I was going to say sulfur, but that was obviously wrong. And then fluorine, group 17, started out with 7 valence electron. You have 7 crosses, so 7 dots originally, and now you share 1 electrons, 1 cross from the oxygen. You now have 8 electrons around each fluorine. Do we have to draw these lone pair above and bottom? You don't have to. You can show the fluorine side by side, and you have the lone pair and the lone pair there. Doesn't matter, because we know in 3 dimensions, the shape of this molecule is going to be linear. Oops, not linear. I don't know what I'm doing. It's not going to be linear. In fact, it has got 2 bond pairs, and it has got 2 lone pairs of electrons. So we talk about VSEPR as stated in the AS syllabus. Your lone pair will repel more than lone pair, bond pair, will repel more than bond pair, bond pair. Overall, you get this shape called nonlinear. And some books will say that this is bent. Some books will say that this is V-shape. This next question, we've got to predict relative oxidizing abilities of fluorine and chlorine. So this is not about going down the whole of group 17 halogens, but it's just fluorine and chlorine. So we're going to go to the E0 values in the data booklet. So in the current 2022 specifications, your paper 1 all the way to paper 4, well, excluding the paper 3, will no longer have the data booklet separate. Instead, it will be inside the question paper itself. So you probably not get a question like this unless the data in the questions, try to guide you like that. So we have E0 Cl2 Cl minus. We always represent this as reduction potential because all the electron potentials in the data booklet, they show you as standard reduction potential. So they are in alphabetical order. The Cl2 adding electrons to give you chloride, that is plus 1.36 volt there. And when I go to the F2, F minus, so further down, alphabetical order, that is plus 2.87 volt. So what can we predict about the relative oxidizing ability? We know that the halogens are oxidizing agent. So what do oxidizing agent do? Oxidizing agent oxidizes the other substance. So they oxidize others. But what happened to itself? Itself get reduced. Itself get reduced. That is the key factor there. Itself get reduced. Well, actually, there's number 1 and there's number 2. Supposedly, the number 3 actually follows from number 2. So itself get reduced. So more positive E naught for fluorine than the E naught than that of chlorine means fluorine prefers reduction more, as it favors the equilibrium more to the right hand side. It prefers to gain electrons more, it prefers to get reduced more, and therefore fluorine is the stronger oxidizing agent. So fluorine is stronger oxidizing agent because it prefers to be reduced more. So that is what the question really wants there. Predict the type of reaction that would occur if you have interhalogen compounds, such that you have one chlorine and one fluorine with potassium bromide. So if you have something like chlorine and fluorine, you are going to imagine that your E naught, well, we don't know which one is going to be which one, but supposedly if you have ClF there, the ClF, when it gets electrons, they can potentially get Cl minus and F minus like that, and then you have 2 electrons. But of course, we don't have the actual values, but what can we say? The value is going to be somewhere intermediate in between that of both of them being chlorine and both of them being fluorine. So they are saying what would be the value? Well, predict the type of reaction that will occur. That would occur means we're expecting it to occur. If it does occur, and both of them are stronger oxidizing agent than bromine, so both of them can oxidize bromide to bromine. If you imagine the oxidizing power straight from AS chemistry, oxidizing power of the halogen, fluorine, chlorine, bromine, iodine, like that. So if bromine is below chlorine, that means these two are stronger oxidizing agent than these. So if you have something which is interhalogen, like F and chlorine, somewhere intermediate, is still a stronger oxidizing agent than that. So obviously you will get a redox equation where you will oxidize the bromide to bromine, and then this particular ClF will undergo reduction. Construct an equation for this reaction. So now they want an equation. So FCl plus KBr. First of all, we know definitely they will go to Br2 as that get oxidized. So Br0 to Br minus 1 in bromide, going to Br0 in bromine. I wonder what's going to happen to the FCl now. So if both of them FCl, this is going to oxidize that, and then this will get reduced. So what I'll get is F2 and C. Nope, I will get F minus and Cl minus. And instead of the usual 2F minus or 2Cl minus, I get 1 of each because I have 1 of that, and I need 2 of KBr, and that balances out the Br, and I will have 2 potassium, so it's Kf and also KCl just to balance the equation. KCl and Kf, that is Cl minus 1, that is F minus 1, that is F. It's a bit hard to think about oxidation number here, but then because fluorine is more electronegative than chlorine, so what I can say is that must be fluorine minus 1, and the chlorine must be the one with the positive oxidation number because fluorine is more electronegative. So going from chlorine plus 1 to chlorine minus 1, you can imagine that as a reduction reaction, and this is your oxidation reaction there. Let me see if that is alright. Yeah, that's probably the best I can do in terms of the information given, isn't it? Okay, so that's it really for these 8-mark questions on, well, actually quite a lot of AS halogen chemistry, but also quite a bit of this A2 electrochemistry there.